times c, then the fraction a over b is the larger fraction. If, on the other hand, the amount b times c is the larger of the two cross products, then the c over d is actually the larger of the two fractions. Now you might say to me, oh my word, I'm so confused. Well, don't be. Here's a verbal way to say the rule I just mentioned. Multiply each numerator with the other fraction's denominator. Find the amount which is larger and identify the numerator that was used to get that amount. Then the fraction with that numerator is the larger fraction. The key here is which numerator gave you the larger multiplied amount. So let's go back to 8 over 13 and 12 over 15. We saw that 8 times 15 equals 120, and 12 times 13 equals 156. The 156 is larger than 120, so the 12 times 13 is the larger of the two cross products. The numerator used there is the 12 from the 12 over 15. And that means that 12 over 15 is a larger amount than 8 over 13. And that's a really nice result. Now, in a few lessons, we're going to talk about converting fractions to decimal numbers, and that'll give us another way to see which fraction is bigger. But until then, I really like this cross-multiplying trick. So let's look at one more example of this just to make sure we have it down. I'd like you to think about it first before we work through the details. So on your own, determine which of the following two fractions is larger, 7 over 8 or 10 over 12. Okay, we're just going to do these two cross multiplications and we're going to find the larger of the two amounts. So as I go through that, I see that I need to do 7 times 12 and 10 times 8. Well, 7 times 12 equals 84 and 10 times 8 equals 80. Now those two numbers are close, but 84 is bigger than the 80. And so that means I need to look at the 84, which is the 7 times the 12. Which one has the numerator there? Well, it's the 7. That's the part of 7 times 12 which includes a numerator. And that means that the fraction with 7 as a numerator is larger. And therefore, 7 over 8 is actually larger than 10 over 12. It's that simple. Okay, I'd like to shift gears now once more as we think about fractions in general. I've already talked a bit about reducing fractions which are not already in reduced terms, or what some folks sometimes call lowest terms. We've talked about that for a while. To be honest, reducing fractions just takes some practice in trying to identify or spot what some of those common factors are between the numerator and the denominator. Bottom line, it just takes practice. So I encourage you to work through several examples of reducing fractions. This is also going to come in handy in later lessons when we start combining fractions with addition, subtraction, and so on. So for now, let's just do one more problem with reducing fractions right here, and then we'll move on to a few more topics. Let's reduce the fraction 90 over 450 into reduced terms, or lowest terms. If you think you can do this one on your own, give it a try. All right, the key here is to start looking for common factors in the numerator and the denominator and to divide them out of both of the numbers. I should point out that this process can take very different tracks for different people. In this case, for example, I see that a 5 and a 2 can be divided out of both the numerator and the denominator. It's okay to divide out the 5s first and then the 2s. It's also perfectly fine to divide out the 2s first and then the 5s. In fact, it would also be fine just to divide a 10 from both top and bottom, from both the numerator and denominator. All of these approaches would be fine, even though they seem very, very different. The key is this: no matter what path you take to dividing out all of the common factors, whatever fraction you end up with needs to be the same. And there's only one fraction which is equivalent to 90 over 450, which is in reduced terms. So it's not the path we take, it's whatever we end up with at the end, which is really the important fact. So Let me start here by dividing out the 2 from both the numerator and denominator. I have that choice. Feel free to pause the lesson here and compute 90 divided by 2 and 450 divided by 2 using long division. Now, once you've divided out those 2's, you should find then that 90 over 450 is equivalent to 45 over 225 after you completed those long divisions. The 45 is coming from 90 divided by 2. The 225 is coming from 450 divided by 2. Excellent. But we have to keep going because our fraction now, 45 divided by 225, is not in lowest terms. Let's now divide out that 5 from both the numerator and the denominator. When you do that, you should have 9 divided by 45. Now what? Are we done? Well, no. It's pretty easy to see that 9 has a divisor of 3 in it, and it turns out that 3 is also a divisor of 45. So now we need to divide a 3 from both the numerator and the denominator. When I do that, it leaves me with 3 on top, because 3 times 3 is 9, and it leaves me a 15 on the bottom, because 15 times 3 is 45. And wait a minute, there's still a 3 in both the 3 and the 15 in the numerator and denominator. I have to do the process again. When I divide those 3's out, I will have 1 on top and 5 on the bottom. And there's nothing more I can do to reduce that fraction. So that means that 90 over 450 is actually equivalent just to the small fraction 1 over 5. But how would I check that? I mean, you may feel a little uncomfortable with that answer. Well, just do the cross multiplication trick. You have 90 over 450 and 1 over 5. If they're really equivalent, then those cross multiplication amounts have to be the same. Well, let's check. 90 times 5 is one of those cross multiplications, and that's 450. You can do that just like we've done in previous lessons. And then the 1 times 450, well, that's just 450. Anytime you multiply by 1, you just get the other number back. So 1 times 450 is 450. Those two amounts are the same. And that means that since the cross multiplication amounts were the same, the two fractions, 90 over 450 and 1 over 5, are actually equivalent fractions. Now, as we close out the lesson today, I want to mention 2 more vocabulary terms which are related to fractions. They're called improper fractions and mixed numbers. An improper fraction is a fraction whose numerator is actually larger than the denominator. So fractions like 11 over 5, 3 over 2, and 200 over 130 are all improper fractions. I'm honestly not sure why these are called improper, but it almost sounds like there's something wrong. Well, you know, like when someone tells you your behavior at the dinner table is improper, it usually means you're doing something that you shouldn't. Well, here it's not that much of a problem to have improper fractions. However, there's a way to rewrite improper fractions so that the numerators are smaller than the denominators, and these are called mixed numbers. A mixed number is a whole number that is combined with a fraction. So for example, 2 1/3 is a mixed number, and 5 1/2 is a mixed number, and so is 10 2/3. These are very common numbers if you think about it. When you look at a sheet of 8.5 inch by 11 inch paper, the 8 1/2 is a mixed number. And how many times do recipes say to add something like 3.5 cups of flour to the mix? So as we close, let's just show how you can work between improper fractions and mixed numbers in the following way. Let's convert a number like 25 over 4 to a mixed number. Well, here's the basic idea. How many times does 4 go into 25? Or, if I said it a bit differently, how many 4's can you subtract out of 25? Well, the answer is 6, because 6 times 4 equals 24, which is less than 25, but 7 times 4 equals 28, which is larger than 25. So we can actually pull out a 6 from the 25 over 4, and how much of the numerator is left after taking out that 6? Which is like taking 24 out of 25? Well, just 1. So 25 over 4, which is an improper fraction, is the same as 6 1/4 as a mixed number. And there you have it. Now, I'd like to close this lesson by doing one more conversion of an improper fraction to a mixed number. The idea is the same as it was before. I need to ask this question. How many times does 3 go into 47? Well, that's just a long division problem. So feel free to pause the lesson here to complete that long division. Now, what did you get? Well, the answer is 15 with a remainder of 2. And guess what? That tells you all you need to know. 47 over 3 is the same as the mixed number 15 and 2/3. The 15 was the quotient from that long division problem, and the 2 was that remainder at the end. So I know that the improper fraction 47 over 3 is the same as the mixed number 15 and 2/3. Now, as we close this lesson, I'd like to make sure that you feel comfortable with these fractions. Lots of terminology that we've walked through today, including these ideas of mixed numbers and improper fractions, but even things like numerator and denominator and equivalent fractions. Next time, we're going to start working with adding, subtracting fractions. And it's going to be very important that we understand what we've done today in order to work on the material in that next lesson.